Hi, welcome to the episode of Collision TV. In this week, we are going to look at something completely different. In 1880s, the automobile was the latest achievement in the transport, and 2 decades later, the Wright brothers took humanity into the skies with the first successful aircraft for over a century. The question has been asked, could we successfully merge the two technologies? The first serious attempt was made in 1917 by the aviator Glenn Curtiss. His airplane was powered by a rear-mounted four-blade propeller. It did leave the ground, but it couldn't achieve full flight. The next notable design was the Aerocar by the inventor Mal Taylor. It successfully flew in 1949, but only 6 were ever built over the decades. Many have tried to crack the code of the flying car, but no one has succeeded yet. Recently, a team out of Japan showed their latest efforts to achieve this dream. But will they succeed? In this video, we will take a look at this, but then we will ask deeper questions and branch out into the wider electric aircraft market. We are going to uncover some problems and solutions. Let's get into it. Last month, Japan showcased a flying car built by the company SkyDrive, who was sponsored by Toyota. The vehicle is powered by 8 independent electric motors and has been in development since 2014. So it was only publicly demonstrated for the first time last month. I know what some of you are thinking. That's not a flying car, that's just a passenger drone. Well, this is just the test phase. The next step will be to add wheels. From the aim to go for commercial manned flights in 2023, the final product will cost around $1,000 US. They hope to decrease the cost by 2030. SkyDrive's unique selling point is that this product is one of the most compact and light flying car designs out there. There are several companies developing similar technology, including Airbus, as well as Toyota Porsche is teaming up with Boeing, and in January, Hyundai and Uber announced that they were collaborating on an all-electric air-taxi. Morgan Stanley analysts state that they expect urban air taxis to be common by 2040, with a global market expected to be about $1.5 trillion. Less emissions, cheaper running cost, and simpler maintenance. Let's take a closer look at these points. Electric aviation has the promise of greatly reducing financial and environmental costs of existing air transport. According to the Australian Airport Association, the biggest airline costs are fuel and maintenance. Fuel makes up to about 27% and maintenance 11%. The running costs of powering electric aircraft is low, and they are intrinsically less complex than their fuel counterparts too. Fewer moving parts and a simpler design mean less need for maintenance. Electric aircraft could also improve the efficiency of local airports and allow airports in more diverse locations. Today, a lot of airports often have to comply with pollution regulations. Airports are freed from these regulations, improving efficiency, reducing costs, and with the added benefit of being allowed to be placed nearer to the city centers. This even opens up opportunities for the new kind of work arrangement, though this has become less relevant recently with more people working from home these days. Let's take a look at some problems. Firstly, battery is the key issue of affecting the uptake of electric aircraft. Is the need to ensure enough battery energy density to support commercial flights. The ball is rolling. Graphene solid state and aluminum air are recent developments that are looking likely in the next few years. By 2022, 9-seat planes could be doing short-haul flights about 500 to 1000 kilometers. For example, the Israel Film Aviation has built a 9-passenger aircraft that is rated to fly up to 1000 kilometers at an altitude of 3000 meters and at a speed of 440 kilometers an hour. It's expected to enter service in 2022. The key here was to use aluminum batteries instead of less practical lithium-ion batteries. Aluminum batteries have a specific energy of about 1300 watt-hours per kilogram versus lithium-ion at about 260 watt-hours per kilogram. So even when the battery issue is solved, there's still one thing that's holding back the future of this industry. It's something that no one's really talking about it, and it doesn't really seem that many people are thinking about this either. That is the conundrum of the charging standards. Imagine for a second, if every car maker's fuel pump was different, how inconvenient and inefficient would the automotive industry be? That's essentially what's happening for electric cars. The chargings provided by different manufacturers don't agree with each other, and even the same manufacturer can have different charges for different regions. Tesla in the United States uses a different standards. It's simple and compact but has limited voltage capacity. Tesla has another charger for Europe and Australia, but they also have yet another charger for China and India. At the start of 2018, Electro-Aero was the first to obtain approval from an aviation regulator to commercially operate an electric light sport aircraft for recreational flight training. Since then, they identified the need for standardization aviation charging to help accelerate the uptake of electric aircraft. This is so each charger automatically knows exactly what plane is being charged and how much the subsequent energy cost will be. No apps, no account logins, or any other hassles that current electric vehicle sector has to deal with. While the charging standard is designed to cater up to 250 kilowatts or about about a 1 to 4 seater plane. There is eventually going to be a need for megawatt power levels, but that's for the future right now. It is good that this problem is being looked at, and once standardized charging is developed and adopted, it will bring us one step closer to an airborne electric air taxi feature.
Why did it fail in the past? The reasons are: power plant was too heavy, power plant was too noisy, electric motors were not prolific and low weight at this time in development, carbon fiber structures didn't exist. These vehicles were trying to be all things. They were trying to be a good car and a good aircraft, and unfortunately they compromised on both of those design challenges. So why will it succeed in the future? Well, things have changed. Yep, we now have high power density batteries, we have low mass electric motors, we have low noise fans, we have lightweight carbon composite structures. And now across the world, 120 of these concept vehicles exist, and they're increasing at a rate of about 1 a week at present.
I'm curious to know your thoughts on the electric aircraft industry. Do you think that we are a mere 5 years away from seeing flying cars become a reality, or do you think that this is all going to take much longer? Let me know your thoughts in the comment section below. And you have been watching Korean TV, so I will see you again in the next video.